general, there are two types of computational megastructures in science fiction: the Matryoshka brain and the Jupiter brain. The Matryoshka brain, or M-brain, is a computer built around and powered by a star. The Jupiter brain is very similar, except it's built around and powered by a large gas giant planet instead. Both are entirely theoretical designs, but both aim to provide the most advanced computer imaginable. If humanity had access to either of them, it would pave the way for an all-new world. The Matryoshka brain is probably the most well-known of the two, though. The concept was first put forward by Robert Bradbury in the late 1990s, and it relies heavily on Dyson spheres, another hypothesized megastructure again built around a star, but this time to siphon stellar energy. The difference is that, where a Dyson sphere on its own could be a power generator for all of humanity, an M-brain generates the same amount of energy but uses it all up on itself. It functions off of a star's worth of power. There have been a number of designs suggested in recent years, but the common and crucial aspect of all of them is that a Matryoshka brain would actually be made of multiple Dyson sphere-like structures. The spheres would be built around each other, with the smallest on the inside as close to the star as possible, and then a larger one built around it, and then an even larger one around that, and so on. That's why it's called a Matryoshka brain, after the Russian Matryoshka dolls which continually fit inside of each other. It's built like this to be as efficient as possible, however. This way, the brain takes absolutely all of the energy produced by the star, including any waste energy which might be lost by the inner spheres. Finally, it would need to be made of a hypothetical material that doesn't exist yet, a material often dubbed computronium, which would allow for every single cell of the brain to compute. Vast computers like this have appeared in science fiction before now, sometimes with specific purposes, and sometimes not. In Douglas Adams's The Hitchhiker's Guide to the Galaxy, for example, the computer Deep Thought is built to answer the ultimate question to life, the universe, and everything. It famously determines the solution to be 42. Another example is the Traveler, a giant orb that hovers above Earth in the video game series Destiny. Everybody in the game's galaxy wants access to the Traveler because it can help species to evolve, but nobody knows who built it, why, or where it actually came from. Which begs the question, why would humans want to build a Matryoshka brain? Craving the answer to one very specific question, like the ultimate question of life, the universe, and everything, is certainly one reason. But would that really be our main motivation? Today's supercomputers, lowly Earthbound machines by comparison, but super nonetheless, are used largely by institutions like universities or space agencies or by the defense industry for national security. The Electronic Numerical Integrator and Computer, or the ENIAC, was one of the first digital computers in the world, built at the University of Pennsylvania in the 1940s. But we've come a long way since then, and among the most important applications of the best contemporary machines is that they help us to complete enormous calculations for space missions and for other research into the cosmos. But they're also used for more everyday purposes too, like predicting the weather. A Matryoshka brain would have the potential to go so far beyond tasks like these, though. Its computational power is still frankly unimaginable for us, even compared to our most cutting-edge designs in the 21st century. If we were able to harness control over it, then we'd probably set it to work formulating a unified theory of everything, providing us with an answer to all of our scientific problems. In the hands of a sufficiently advanced society, a Matryoshka brain could handle the logistics of a galactic civilization, or it could map out the entire universe. But unfortunately, if we really did build this thing, then it might never be capable of any of that. It would be a reflection of its creators, of human beings, and so it could well prove to be as fallible as we are, therefore churning out answers as ultimately useless as Deep Thought's 42. A star-sized computer could be more than just confusing, though. It could easily be dangerous. Really dangerous. A Matryoshka brain could be seen as essentially a high-powered artificial intelligence, for example, and it wouldn't take long for that AI to get out of hand, having already left what we currently know as the technological singularity withering in its dust a long time ago. We, the humans trying to maintain some control over this thing, could find ourselves quickly discarded and left behind. Failing that, what if we built a Matryoshka brain and then it got hacked by some other force, from the inside or even from the outside? This wouldn't just be personal details on the line, but planetary details. The inner workings of whole star systems would be at risk, all housed inside one giant, multi-layered, many-faceted megastructure. This supercomputer would be the beating heart of any civilization that had it, so it would be the primary target for anyone or thing trying to infiltrate it. And hey, even if it wasn't hacked, would life under the Matryoshka brain really be so good? Even today, with our relatively basic machines, technophobia is common in society. People fear and distrust the relentless march of technological progress. But that would get even worse if we were to build a genuinely godlike computer, one that really could rule our lives. How would you feel if everything was decided for you by a shiny, star-sapping system in the sky? All of that said, it's not as though a Matryoshka brain would automatically become some kind of superweapon, or a means of ultimate control. So we'll finish with arguably its most exciting application of all: simulations. Various theorists and writers have mused that the chief task for a Matryoshka brain would be to run simulations of, well, everything. These sims could then be the basis for huge sprawling experiments, looking at how every possible combination and timeline in the universe could play out. In this way, it could be said that a Matryoshka brain would birth a multiverse, as it would provide us with whatever parallel universe we desired. And if, by the time we built it, we were also capable of mind uploading and digitizing consciousness, then a star-sized computer could even have the potential to create an afterlife. Place every bit of human information onto it, and it could become some sort of post-biological haven. How then, you ask, do we know that we're not already inside a Matryoshka brain? How do we know that we haven't already been translated onto the most advanced computer imaginable to live out our days in this particular place on this particular timeline? Well, as with most imaginings of the simulation hypothesis, we don't. It's the kind of existential conundrum that humanity, at its current level, might never work out. For all of the reasons we've mentioned, the idea of a Matryoshka brain can be divisive. For some, it would represent the pinnacle of technological achievement. For others, it sounds frightening or maybe even pointless. But regardless, there are a couple of fairly large obstacles in the way of us ever actually constructing one. First off is the fact that the new material we mentioned at the start of the video, computronium, doesn't exist. And the general idea of programmable matter is incredibly advanced and still at its early stages. Second is the fact that to power a star-sized computer, we would first need a star-going spare. We couldn't just build one around the sun because we need the sun to live. So that means traveling to a completely different star system to make it happen, which just isn't feasible for humankind. We would stand more of a chance with a Jupiter brain, the similar but smaller machine built around a gas giant planet instead. Both Jupiter and Saturn would offer comparatively close-by options for this. But even so, we're currently centuries away from the tech needed, even by the most optimistic of estimates. In theory, a computer the size of a star, or any celestial body, is possible, and if it ever actually happened, it could revolutionize life in the universe. Or we might never be able to comprehend what to do with it. And the best we could ever hope for is 42. And that's what would happen if we built a star-sized computer.